Hello, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. Now I would like to introduce today's presenters and go over today's agenda. With us today, we have Joydeep Sanyal. Joy is the Product Line Manager of General Industrial at Smiths Interconnect. And also joining us today is Kim Haas. Kim is a Sales Engineer with Smiths Interconnect. So now I would like to go over our agenda and a few points we'll be talking about today. So we're going to find out more about what test and measurement really is. We are going to examine the challenges with test and measurement applications and the role of connectors. And we're going to share Smiths Interconnect's experience in helping with test and measurement equipment designers. After that, we will have a live Q&A session, so get your questions ready. And with that, Joy, I'm going to pass things along to you to get the actual webinar started. So Joy, go right ahead.
Thank you, Katie. Good morning, good afternoon, good evening from whichever part of the world you are joining. Let me start by giving a little bit of an overview of Smiths Interconnect. For those of you for whom Smiths Interconnect is not a name that you have come across, it might be interesting to know that Smiths Interconnect is a leading provider of technically differentiated electronic components, subsystems, microwave, optical, and radio frequency products, and that connects, protects, and control critical applications in commercial aviation, defense, space, medical, rail, semiconductor, test, and industrial market segment. What technically differentiated means a lot to our customers, because when we go across the next few slides, you will see how the way we approach design is in some ways quite different to many other players in this market. We have got over 60 years experience in this industry. We've got more than 15 sales offices with 15 manufacturing sites and 12 R&D centers dotted around the different parts of the world. We've got a comprehensive product portfolio which technically differentiates with advanced engineering solutions. The way we are structured are in different business units, addressing different customers and customers' needs. For example, connectors, fiber optics, RF component, semiconductor test, and Smiths Interconnecting. We are optimized quality through first-class materials, state-of-the-art development methods that we apply in our design processes or manufacturing processes. And finally, not to mention that we are part of a much bigger umbrella, Smiths Group, which has got a robust financial pedigree and reputable heritage over 100 years. So with this short introduction about Smiths Interconnect, let me move into talking about the core subject about this particular webinar. I'll start with a little bit of an introduction about what is test and measurement, because it can mean a lot of different things to a lot of different end-use applications. But before I do a slightly deeper dive into it, it's worth reminding ourselves in some ways is the classic saying that if you can't measure, you can't control it, right? I suppose it's quite an obvious one. So test equipment is data acquisition for simulation, validation, and diagnostic tool for testing a variety of different electronics in various industries and end-use applications, including in defense, aerospace, automotive, industrial automation, just to name a few, right? The list is much longer. Now, the role of a test equipment, it depends, but in general, if you sum it up or try to really sum it up at a much higher level, it includes a variety of instruments that carry out and evaluate the results of functionality, performance, quality, stress test. All of them are done on electronic devices and systems, either during the design phase of an electronic equipment or during its production phase, to ensure that whatever is leaving our customers' factories they are of sound quality. Now, when we talk to various end-use applications, and as I said, those end-use applications can cut across multiple industries. There are certain themes of challenges that in some way resonate across all the different applications in various industries. The first one I would say is signal integrity. The second one is mating cycles and insertion force. And the third one is space, in the sense how big or small the connector is. Now, as we go along the rest of the presentation, I will try to bring about a link between signal integrity and mating cycles and insertion force and try to demonstrate how, to some extent, they are quite intricately linked over the life cycle of the connector. When we look into this end-use application across multiple industries, our design philosophy is not to just design or bring about a connector for that end-use application based on the hard technical requirements. Let's say this has to be the amperage, such and such has to be the volts of it, et cetera, et cetera. Our philosophy is a little bit more holistic in so much as we look into the customer's total cost of ownership centering around the connector. And when we talk about cost of ownership, we not only include the obvious one, what is the initial purchase cost, what is the cost of installation, because how quick it is for our customers will it take them to install it. And when I say installation, even in our thought processes, we include things like how much will it cost to even purchase a tool? Do they require any special tooling? Does the customer require any special training to use that tool, etc.? The cost of operating it, of course. And finally, and perhaps one of the most obvious one that should be taken care of, but we have seen across years and years in this industry that often many players put this in the back burner of cost of not operating, or more importantly, cost of poorly operating, because it's not often that connectors go through a catastrophic failure. But what often happens in our experience is that connectors poorly operating. And what is the consequence of that? Has anyone put a dollar figure against that? That how much does it cost to an end-use application of a poor connector? Often this is not accounted actually in any discussion. And across the next many slides, we will try to bring about these sort of themes into life so that you're able to understand where Smiths Interconnect bring about a change and in some way a paradigm shift in the thinking process in the connectors industry. Now let's take a step back and understand a little bit about some general failure mechanism of connectors. As I said in the previous slide, right, it is often cost of poor operation that causes deterioration of the overall performance of a system. Now, typically speaking, and I stress on the word typically, connectors in these sort of applications fail due to one of these reasons. It can be temperature, and by temperature I mean the thermal expansion and contraction that results into low frequency micro movement of the contact surface. And that will cause fretting action. And what does the fretting action do? I will cover that in one of the next slides. This creates, this sort of movement creates some form of mechanical stress, and it creates deterioration within the contact and therefore the performance of the connector. Vibration load. A vibration can cause large deformation or stress around the contact material, leading to fatigue, wear and tear due to removal of plating material. And then it's a bit of a vicious cycle, right? Once that process has started, it increases the contact resistance, and then you go through that chain of poor, from a good to a very poor performing connector due to increase in contact resistance. Thirdly, humidity. humidity deteriorates material properties over time. It causes galvanic corrosion at the contacts, and then as that failure mode of corrosion sets in, it again, like as I said in the previous one, it creates that vicious cycle where it increases the contact resistance and it brings about from a good to a poorly performing connector. And finally, contamination. The surrounding environment, if it's in an industrial environment where you have got environment polluted or contains pollutants like sulfides, chlorides, nitrites, hydroxides, or ammonium salt. And it just creates a failure mechanism to set in. In our experience, what is quite interesting is it's not just one of these pillars that set in or set the process. It perhaps initiates the process of good, from a good performing to a poorly performing connector, but it's often a combination of one or more of them that brings about a failure of a connector. And what we have experienced is what is central in this process to mitigate with this risk is the choice of a contact technology, because often contact is being the heart of the connector, is the one that, if taken care of, in the sense that if it's chosen, if the right contact technology is chosen at the beginning, then often you get a superior performing connector for a longer period of time, because whilst many of the things that I talked about, temperature, load, vibration load, humidity, contamination, is maybe a natural presence, if you like, of the application around it. But by choosing a right technology, you are basically either removing those failure modes or in some cases delaying the inevitable. So we want to, through this presentation, we want to perhaps just highlight, given the time that we have got, 4 products in particular, and a few different contact technologies that act as the foundation for our design. I'll talk a little bit about L series, which is the high-density modular connector, HN series, which is a high-density mini-modular connector, M12, which is a rugged circular connector, and KA series, which is a PCB connector. And as I said, underlying that is Smiths Interconnect's foundation around the contact technology and the innovation around contact technologies. So let's start with the contact technology. In vast majority of the applications that we have got connectors, we typically use the Hypertech hyperboloid contact technology. Forgive me for some of you, you might be well conversant with this particular technology, but for those who are new to this technology, please bear with me and just let me just take you through this slide to explain you what is this technology and how is this technology different from perhaps anything else that you see in the market on a regular basis. So the fundamental part of the hyperboloid contact technology is around the low contact resistance. And if you remember, I talked about the failure mode, and I mentioned that how some of the failure mechanism that set in ultimately lead to increasing contact resistance. What this hyperboloid contact does is that it reduces that probability through a number of different mechanisms. It has got, as you can see on the picture on the right, it's got a 360-degree wiping action. Therefore, it kind of cleans it in that process and doesn't let that failure mode kind of set in. Typically speaking, it does 30% more current carrying capacity for the same diameter of the socket, which in turn results in an overall space and weight saving, because if you need a particular electrical spec, then again, typically speaking, our connectors are often the smallest in the market, giving you that advantage of space and weight. Shock and vibration, many of these connectors operate in extremely arduous environment, demanding environment that requires high shock and vibration, which in turn results in, or doesn't let the fretting corrosion set in, resulting in a longer life cycle of a connector, which ultimately, the ethos, if you like, is that in some way we don't want our customers to think much about connectors once they have been fitted in. So it's a bit of a fit and forget connector is what we want to aim for. Low mating force. If you have played with one of these connectors, you would experience how easy it is to mate and demate this particular connector. And why is this important? Because particularly if you have an application where you require multiple mating, demating cycles, then in any other contact technology, you would, knowingly or unknowingly, inadvertently perhaps, if you're not conscious about it, you set in that failure mechanism of fretting or creating that force on when you are kind of pushing the pin onto the socket, and then that goes into the vicious cycle of increasing contact resistance, and that starts the cycle of good to a poor performing connector. Reducing the cost of ownership, as I said in my previous slide, is one of our key philosophy of approaching design. Now with this, let me stress a little bit on, or take you through the L-series high-density modular connector. So the L-series modular connector is a rugged high-density modular connector which employs do-it-yourself system based on the principle of building blocks. And perhaps, as the wise people say, pictures tell 1,000 words. As you can see on the picture on the top, it's almost like bits of Lego blocks, right? Isn't it? You can just take it. The L series is composed of two elements, as you can perhaps just about make sense, right? On the picture, it's got variety of different types of modules and frames. And then depending upon what your end-use application is, you can just configure the way you want to configure, and there you go, you've got a connector in front of you. Now, the beauty of this connector or this family of connector is that depending upon your end-use application, you can find within this one product family a variety of different modules. You name it, from signal to power to coaxial to fiber optics to pneumatic, you name it, right? You get the whole raft of different application requirements bundled into one product family. And then into a custom arrangement which ultimately lends itself into a single connector frame. If you look at the key kind of the features and the benefits of it, because this connector is using the hyperboloid technology, as I mentioned in my previous slide, it brings with itself that feature and the benefit of low insertion and extraction force. And again, I'm in the perhaps risk of repeating myself again here. Why is this important? Because when you've got so many different contacts, right, and pins trying to mate, then you invariably create some additional force or unintended force onto this mating process, which ideally is not what you want. Of course, this is a high-density connector. As you can see, you can have a number of different configurations depending upon your end-use application. And why is this word modular so kind of a beauty in itself is because if you're particularly building a test equipment or a test system, which in itself can have its own functionality expanded, then you can literally change the configuration depending upon your vision of your own end-use application. Given, again, the way that these connectors are designed, it's highly reliable for harsh environments. And harsh doesn't necessarily always mean that it has to be a harsh industrial environment. You will be surprised how a connector is just left in an environment which in itself sometimes may not be quite conducive for its overall health, so to speak, right? So things like shock and vibration. So you might think, hold on, in my end-use application, it doesn't have that level of shock and vibration. But I have seen, or we have seen sometimes, again, things happening. For example, the last thing it comes across in anyone's mind is about a connector, and the test equipment gets knocked off a little bit or kind of gets moved around, and you create those sort of scenarios around the life cycle of the connector and the test equipment, and it sets in the failure mechanism. High current rating, then you've got the low cost of ownership overall, which is something that is central to our design philosophy, and design with flexibility, because what is quite critical and quite central to this particular design process is the metal back shell that the hood that you can see can come in either metal or plastic. It's got building blocks of different custom modules, which I mentioned about. It was fixed and snapped in contact version, jack screw available for quick connect and disconnect. And finally, the floating mount for blind meeting is also available so that it makes your life of connecting and disconnecting in a blind meeting operation easy. Right. The next one is N series, often also in some parts of the world also known as the H series. It's a high-density mini-modular connector. Now, I'm going to speed up a little bit on this slide because in some way the philosophy here is exactly same as that of the L series, only the fact that this can pack in a lot more modules, and as you can just about see on the picture on the slide, that how dense it can get really. It has got primarily two different types of contact types, signal and coaxial, and it can be combined exactly like in the L series. A number of different combinations and configurations that you want. The concept, if you like, of the frames, the hoods are very similar to the ones that I mentioned in the previous slide. So without the risk of repeating myself, I'm going to perhaps just show you kind of the point that the L series and the HN series family have got very similar features and benefits, and therefore, over many decades, it has seen a permanent place in many end-use applications because of the benefits it brings to the end-use customers' end-use application. So with that mention about the contact technology and about to the modular range of products, why don't I spend a little bit of time putting these two products into perspective, right? You might be, for those who may not be conversant with these products, you might be thinking, where does this product get used and how good they are? So let me take you through one success story that is very close to our heart because it is one of those success stories that is quite recent in that sense. This is for an ultrasonic transducer testing. It was for a test equipment that was being built for a sensor. So the situation was that one of our customers from Far East Asia was looking for an innovative interconnect solution to support their future sensor requirement to increase production output. They, of course, as you would expect, did a lot of due diligence in finding and looking around what's available in the market today. And the requirements was primarily not only, of course, one has to, of course, meet the technical requirements, but more importantly, the high quality and the reliability that they were looking for Because remember that the test equipment that they were building was, in some sense, the golden sample or generator of the golden sample, that was the final gatekeeper of making sure that nothing leaves their factory with poor quality. So they, as I said, they did the due diligence, and then they finally selected the N-series unimodular connector with analog signals and coaxial RF transmission. Now, why did they choose after kind of scanning the market? Because of a number of different things that kind of brought home the value of Smiths Interconnect's proposition. High mating cycles to guarantee stable connection, bringing back the concept of the hyperboloid design. The metal housing, withstanding rugged operation, multiple plugs and unplugged cycles that was required in this particular application. And finally, the right size on the dimension to be able to fit onto the test hardware box. Additional features such as alignment guide pin that would ultimately help to prevent broken contact due to aging or mishandling due to human error. If you bundle all these things together into one connector, they just felt that if you, across the entire life cycle, as I said, from a initial purchase price to the cost of installation to cost of operating to the cost of non-operating or a poorly operating connector, they felt that this is the best solution that they could get in the market, and therefore they chose the N-series for this application. So, given the success story, let's then move back into talking a little bit about another product, which is M12. Now, often when I talk about M12, I get sometimes, audience or customers giving a funny face. M12 is M12. What is so different about M12? There's a lot of different connectors of M12 in the market. However, it's interesting to see that the ones who kind of done or did a set of comparative studies, they understood the true value of this connector, which is of course built on the platform of the hyperboloid contact technology, and they felt for a high reliability application how crucial the M12 connector from Smiths is. So Smiths Interconnect M12 is a robust and a compact connectivity solution that was initially designed to address specific environment where space and weight are of key concern. Now, our design is not only robust from a reliability standpoint, because of the use of hyperboloid contact, without again risk of repeating myself, all the failure modes that you knowingly or unknowingly or inadvertently set into the process. So that is why sometimes it is quite vital to have that contact technology that ultimately drives that performance. And of course, working around it is the ease of use of unparalleled reliability that brings everything together into one little body. So in a real-world industrial operating scenario, we have seen that the M12's comprehensive sealing properties delivers not only the contact technology that we talked about, but even the sealing brings about a competitive edge by ensuring its uninterrupted signal integrity, which keeps the dust out, the moisture out, the dirt out, oil out, all the sort of things that I talked about, which are a perfectly conducive environment to set in a failure mode to start, and then drive a good to a very good performing connector to a poorly performing connector. So in terms of the features and benefits, it's got, I'm not at risk of repeating again, the hyperboloid contact system, which I said, it's built on that platform of contact technology. But from a signal integrity standpoint, it's got a 360-degree shielding connection, protecting against any form of interference. It's got a versatile cable clamp allowing you to accommodate a variety of different cable dimensions. Once you start putting this together, you will see what wonder it brings about in terms of ease of use and simple, what looks like very simple engineering principle. When you put those principles all together in one little body, it does wonder in form of clipping arrangements, so that when you're dealing with really small diameter contact, you're not kind of fiddling with things kind of falling off or kind of, you're not misplacing things, right? So it's nice clipping arrangement, keeps things neat and nice, neat and clean in terms of ease of use. So it's just that if you use assembly and the use putting things together minimizes the time it takes. Enhanced functionality in terms of the developing the time saving through the improved production yield, therefore slight contact retention that I talked about a few minutes ago about the clipping arrangement, and simplified assembly, high contact retention force, vibration protector. So again, all of these things, right, when you bundle them together, you will see when you're spending thousands of dollars or pounds or euros, whatever your currency is, of building a highly reliable electronic test equipment in some form or another, the last thing you want is for tens of dollars or euros or pounds to select something that looks good on the face of it, but often in the long run becomes too good to be true. Finally, from a product standpoint, the KA-PCB series, because often these sort of application requires a lot of different PCB connectors, and Smiths Interconnect has got a very broad range of PCB connectors. Here is just one of many examples, which is the KA series, which is, again, was built on the family of hyperboloid contact. It's got more than 2,500 different configurations. The KA series provides a lot of different design flexibility that are not available with other mill standard connectors. The additional KA series supports current rating of up to 9 amperage per contact, low contact resistance, again, going back to the hyperboloid contacts, and the minimal insertion and extraction force. What it does from a benefit standpoint is brings about that flexibility that one needs during the design phase. The rugged connector with straightforward through-hole solder process, right angle PCB solder option, crimp cup, crimping solder cup, wire wraps termination options, offers anything between 2 to 5 rows of configuration with pin counts from anything between 17 to 490 contacts. End guides provide alignment and 36 changeable key combination. The male and the female contact and guides available either in the plug or on the receptacle side. If you look into the contacts, it's quite amazing, or engineering wonderful in that sense that a 0.6 millimeter diameter contact rated up to 4 amperage of nominal current. Individual contacts can be rated up to 9 amperage, and you can see through the technical kind of features of it in our data sheets. And the final part is the beauty of the product is the contacts are removable from the wiring side, from the front release or rear removables. You can easily take it out. Now, with that, I've kind of covered some of the products that we want to talk about, and now I would like to hand over to my colleague Kim, who is going to again put into context some of the things that we talked about into another wonderful case study that Kim is going to take you through it. Kim, over to you.
Thanks, Joy. Sharing the slide yet? Sure. I'm going to talk a little bit about a customer that we've been supporting for many, many years, and they're a global manufacturer of burn and test systems. And this is a customer that's using a couple of the different products that Joy spoke about, both the L series and the KA series. The uniqueness of this situation and really its transferability to other test systems is that they're using these modular and KA series connectors both in the body of the system itself as well as the individual test boards that plug into the system. They've chosen the connectors that they have because of the hyperboloid contact and all of the different benefits that hyperboloid connector provides, including the low current or the higher current carrying rating, the lower contact resistance, and the very low insertion and extraction force. What they're doing in these situations is they're using the L series primarily to drive the power through the system, from the system to the individual boards, and the K series or the KA series they're using to be able to control the signals. So what they've liked about these connectors, frankly, is the ability to transition from one to another as the industry has evolved and as semiconductor chip technology has evolved, and we're looking at increased functionality on those chips and higher power generation required to test them. The hyperboloid contact technology, again, with its ability to support the temperature extremes, the contamination, and the humidity cycling, how it continues to provide a very reliable performance. As the industry has evolved, they've simply gone from one level of L series to the next, gradually increasing power as the industry demands for higher power have increased. So that's just kind of a high-level overview, but essentially what they're doing is having a pin side connector built into the test system itself, and each individual test board has the mating socket side. So as a new semiconductor chip is introduced or a different board, printed circuit board needs to be created for that, those connector side socket side connectors are placed on those boards and they plug right into their existing system. So you can see that that's an example that would be very transferable to any kind of tester system where you're looking to move power and signals from the tester to the individual PCBs. Joy, back to you.
Thank you, Kim. So with that, again, putting things into perspective is a lovely case study, when you bring things together, and how does those connectors end up giving customers that additional benefit. Let me then talk a little bit about some other forms of contact technologies that we have in our portfolio. Again, I'm not going to delve too much deep into any one of them in interest of time, but just to kind of give you a quick flavor of them. So you've got the spring probe contact technology, which is widely used in extreme high density applications. Coaxial technology is quite widely used in many connectors. As I said, even in the L series, we use it. And the hyperspring technology, which is often suitable for low height PCB interconnect, high density applications. And finally, fiber optics, right? So this is just a quick flavor of many other contact technologies that are available within Smiths Interconnect portfolio, many of which we take to develop connectors depending upon the end-use customer's requirements. So with that, I pass it over to Katie for Q&A session. Yeah, thank you.
All right. Joy and Kim, thank you both so much for the presentation, and Kim for the example. So we are going to move into doing some live Q&A with our audience right now. All right, Joy, so let's get into some of our questions here. This one is asking, The case studies you presented are related to the automotive and burn-in test segments. Do you supply connector solutions to other T&M segments as well?
Yeah, the short answer is no. Thank you, Katie, for that question. The short answer is absolutely yes. This is just a very quick flavor with the time that we have got to show a couple of different contrasting applications. But we have got a number of different end-use applications from use of these connectors in, again, name it, from rail applications where the connectors are used for track signaling systems, to automotive industry where simulations required for, let's say, designing and testing new electric vehicles, to some industrial applications that I talked about for the test systems for sensors. There are many more similar examples around different parts of the world. So the short answer is yes, that this connector or these set of connectors are used in a lot of end-use applications, whether it cuts across multiple industry segments, whether it's defense, aerospace, industrial, rail, you name it, right? So it finds itself universally needed in many of the electronic test systems. Yeah.
All right. Thank you so much for that answer. So we have another one here. This person is asking, do you also sell loose contacts, or we have to purchase the whole connector?
So we have got in our portfolio Hyper Series contacts brochure, where we sell the contacts only. However, said that, so again, you can go onto the website and you'll be able to find that catalog and be able to contact us if you're interested in the contacts only. However, we try to work closely with our customers in bringing the best out of that technology when we are providing the connector completely, because in that sense, or in that way, we are able to truly understand the end-use requirements and able to recommend the best solution for that application, which in turn means that we don't try to, shall we say, force-fit or shoehorn a particular technology into kind of a broad brush application in that sense. So yes, we do it, and there is therefore a catalog for it, but our preferred mode, if you like, is to work with customers to develop or recommend you the right connector for your applications. Yeah.
All right. Thank you so much for that answer. So we have one more question left in our queue, Joyce. So this will be the last one. Unless any attendees have any other questions they would like to ask at this time, you can enter them into that Q&A window and click submit. All right, Joyce. So our last one for today. Do your modular and mini modular series include high-speed data modules?
Means again, absolutely. It means I suppose it doesn't take a genius to kind of figure out that where the world is heading. We are all becoming a lot more data hungry in every sense, from our personal lives to our industrial or kind of our professional work life. And so is the case for electronics equipment, that there's a lot more of digital data being transmitted from point A to point B, and therefore our modular, mini modular range of connectors will very soon have the high-speed data modules that will be able to kind of communicate, transfer high-speed data. And if any one of you are in need of one of them, then just give us a shout and we can talk you through that. Yeah.
All right. Thank you so much for that answer, Joy. All right, so it looks like we have one question that popped in, and I think we're going to take that last question offline. So thank you so much for your last minute question. We will get back to you following today's webinar on that answer. So for everybody, thank you so much for being here today. We are going to start to wrap the webinar up right now. As I mentioned, we have a ton of resources in our resource widget, so go ahead and take a moment to grab those before you leave today. There's also going to be a survey that pops on your screen. If you could take a moment to fill that out, your feedback is always important to us. So I just want to say a huge thank you to Joy and for giving us such a great presentation, answering a couple of questions, and thank you so much, Kim, for joining us today as well. All right, and thank you to all of the audience members for being part of this event. Take care, and we will speak with all of you soon.